These are my personal solutions to the week 4 of the course on Swayam portal, NPTEL's course, an introduction to coding theory. Assignment 4, question 1, answer is option 4. Question 2, answer is option 3. Question 3, answer is option 2. Question 4, answer is option A. Question 5, answer is option 4. Question 6, answer is option 4. Question 7, answer is option 4. Question 8, option A. Question 9, option B. Question 10, option A. Now, this is what I have marked on my answers. So, question 1 goes with 4. Question 2 with this. I'm just scrolling for you to see what my answers are, and after this I will start giving reasons. So briefly I want to discuss so that I might, if I'm wrong, please correct me out. Convolution codes have typically a small value of n and k compared to block code. This is in assignment. If you see the notes and if you have done some examples, then you will see that k and n values are small. So in basically in convolution codes, the values of k and n are of order 1, 2 or 3, something like this. Both of them are low in value. So this is a true statement. This is true. This is true. Then maximum likelihood decoding complexity of convolution codes increases exponentially with the increase in constraint length. The constraint length of the code, if it is increased, then memory elements will increase, states will increase, decoding complexity will increase. Suppose there are 2 memory elements, increase to 3, then the states will increase. The more states implies more path on trellis diagram, and so decoding complexity will be increased. So this is true. Convolution codes can be implemented using shift registers. Yes, shift registers are used to make these memory elements work by shifting bits. So these first 3 statements are true. The last statement is false because memory order m of a convolution code has actually effect on free distance. Here it is said has no effect, but that is not true. So this is false. Why does it have effect? If you have some memory order m and you want to see what will be the free distance. In this case, when we make the transfer function, the power of the variable x gives the free distance. If order is more, states will be more forward paths will be there, more forward paths will increase this power. So increasing this power will increase the distance, free distance, which is the minimum having weight between any 2 code words. So free distance is proportional to memory order, and this no effect is wrong. So this is false statement, and we want to mark the false statement. So option 4 is correct. In question 7 we have been given a generator matrix, and we have to prove if these two are equivalent, both of them or individual. And I saw Sachin sir's lecture, live problem solving class, allowed me Sachin sir showed to us that if you have this a matrix, a given generator matrix, if you multiply it the other matrix which you think is presumably equal to this, then some multiple of that can create this. So writing this matrix here and writing this matrix here and appropriate matrix here, then we multiply and then equate the LHS and LHS to find the values, As we find the values and plug in, we plug in and we get the some simpler representation, and solving this allows us to find that LHS is indeed equal to RHS. Similarly, for this one also, I started with the LHS as given here, GD. RHS is the option, and then again plugging in the appropriate matrix, multiplying it for comparing LHS and RHS, plugging in the values and solving gives LHS is indeed equal to RHS again. That means both A and B are equivalent generator matrix of this given generator matrix. So all of these are actually equal. He says this is invertible if this is available. Consider a rate 1/4 convolution encoder with input-output relationship given by this. It is a basic question in which you have been given the behavior of outputs when such inputs, delayed input or direct input is applied. You just draw the circuit and you will find these outputs linked to the inputs and delayed inputs UL minus 1 and UL minus 2, UL minus all that. From here you can write these generator sequences. Generator sequences can be written, for example, for G1, this point U is 1, then delay of 1 is 0 because it is not connected, delay of 2 is connected, so it is 1, delay of 3 and 4 is not connected in generating V1, so V1 takes only 1, 2 values, so 2 ones are there. Similarly, G2, G3, G4 generator sequences are obtained. After getting the generator sequences, you can just match that second one is true. So question 4 is time domain generator matrix sequence. Here you need to use these sequences and read these 4 values and put like this. So 1 1 0 1 1 1 0 1 0 0 1 0 0 0 1 0. So all these are correct and they match up with this, shifting it right ways, and the generator matrix in time domain is obtained. For code word sequence corresponding to this input, so if this is the input, I made this table, I populated 1 0 1 0 1 1 here, and according to the diagram, this is the diagram. I hope you also will be able to draw this diagram. This diagram can be drawn using these equations, and after drawing these diagram and writing these equations, you can populate this table with the input first. This is the input, then you have the delay element, and it is saying initially it is all 1, initially all 1 in the memory order states, and then start shifting one by one and find out V1 is given by U and U minus 2 delay. The exclusive OR operation, you will get these. Filling this up, you will find that the answer, matching answer is option 4. You read this, how do you read this? This is 0 1 1 1, so 0 1 1 1 1 0 1 0 1 0 1 0 and so on. So you've got V1, V2, V3 and V4 output. Here a non-systematic feed-forward convolution encoder is given. You have the delay UL minus 1, UL minus 2 and the input. To make this table, how V1 is made by all 3, V2 is made by these 2, and you can make this. So question 6, state diagram if you want to make, you will write the state which is 0 0. This can be 0 0 can be with input 0 and input 1. So 0 0 is there, and I started populating, and when I noticed, I looked here and saw that these two are unique and these two are actually found. So this is the right diagram. Others have wrong values. So this is wrong, and so only in 2 checks one can make correct identification. Then weight enumerating function, step 1 is redraw it like this, draw the modified state diagram. Step 2 is, if you watch Sachin sir's lecture, you will be able to write all these steps and perform what is needed. So basically you draw this diagram, put weights. So when you travel on the, so what we have is, we have this one, travel, there it is, we have this one, we travel on the paths and put the weights, we find individual forward loop, pairs of non-touching loops, then denominator 1 minus L1 L2 plus product of, the loops, non-touching loops. Forward path is this, you put it into the transfer function formula and you do some simplification, and you will reach this. So this will match up with one of the answers. Being too tired, I am not going for too much explanation. This screenshot is enough for you to, it is self-explanatory, or better watch Sachin sir's lecture. Then free distance, power of the least value of numerator, here I think it was 7, so 7 marked. Encoder conversion code, is it catastrophic? If a 0 output weight for non-zero input weight, this thing can be checked from, I think how I did it was, I looked here in the state table, 0 output weight for non-zero input weight. So this is 0 output weight for non-zero input weight. In this, 0 output weight is here, and for non-zero input weight we don't get a 0 output weight, so it is not catastrophic. We just verified in this definition that 0 output weight should be there for a non-zero input weight. So 0 output weight is this, all zeros, but non-zero input weight is not here, and when non-zero input weight is given 1, then output weight is 111, which is not 0 output weight. So this is not a catastrophic. You just need to read this definition and then check in the state diagram if that happens. If that does not happen, then you will pick no. Control canonical function of convolution encoder is given. Now we have to find generator matrix in matrix form. It has got 2 inputs, so we will have 2 rows. All of them have 2 rows. It has got 3 outputs, so we will have 3 columns. 3 columns are there. The first output, it depends on input 1, and this is input 1, and for the second row input, it is delayed. Here it is delayed connection. So this delayed connection is shown with this. Similarly for the first one is delayed by 2, order 2 delay, and second one is directly connected. Similarly for the third one delay from the top one, and there is no connection from the second input, so 0. So this one is satisfying. These were my solutions for week 4.